Okay, so let's try the next coding exercise. So open the leetcode.com and go to the problem section. And in the search question, in the search bar, basically search the symmetric tree and hit enter. So we have the question number 101, and it's come under the easy category. So we will try to solve this question. So let's click on it. Okay, so let's read the question. Given the root of a binary tree, so we have the root is given. So if you see there is a function is symmetric, uh, one argument is being passed, which is root. Check whether it is a mirror of itself or not. So we just need to check. So it means it is whether it is a true or false. We just need to return true or false. That's why it is returning boolean. Just we need to return whether true or false. So we need to check whether it is a mirror of itself. Then what is mean by the mirror of itself? So as an example, so let's suppose consider this tree one. So one is only one node, so that is fine. Then we have to just check whether the left hand side and the right hand side of the root node is the mirror of itself. So 2 2, which is fine. If you see in the mirror, which is fine. Then 3. So whatever the 3 is here, then in the mirror the 3 will come on the right hand side, and the 4 is on the right hand side, then in the mirror the 4 will come on the left hand side. So this is exactly the mirror representation, so the answer is true. If you see the another example, we have the root, we have the 2 2, we have the 3 3. If we just see the elements on the left hand side and the right hand side, then we might say it is a mirror, but no, it is not a mirror, because if on the left hand side it is coming on the right hand side, like let's suppose like let's see the left hand side of the root element, which is 1. So 2 and 3 are the left hand side, 2 and 2, which is fine. Now you see the further element 3 and 3. So 3 is on the right hand side of the 2. So this one where I am moving the cursor. So in if we see in the mirror, it should be on the left hand side, but on the left hand side it is null. It is showing on the right hand side. This is not a mirror, so it is false. All right, so we will do this question. So let's see, like there are two approaches to solve this question. One is the recursive and one is the iterative. So we will solve by using the both the way. So if you just think, let's suppose we don't know how to solve this question, but if we just think, so we need some pointers, like because we need to compare both the elements side by side, right? So one pointer from here, one pointer from left hand side, one pointer from the right hand side, one pointer from the left hand side, one pointer from the right hand side. All right. So it means we need at least two nodes, two pointers, like one which will go on the left hand side of this tree, and one which will go on the right hand side of this tree. So in both the recursive and the iterative approach, whether you will do with recursive or whether you will do with iterative, you need two pointers, because we have to traverse the left hand side and the right hand side, and we need to traverse parallelly. That's why we need, because we need to compare 2 and 2, we need to compare 3 and 3, we need to compare 4 and 4. That is a different matter, like how we are going to implement, like because this 3 is on the left hand side and this 3 is on the right hand side, we are expecting on the right hand. That is a different method, like matter. But we need at least two pointers. All right. So and if you scroll down, let's read the constraint. The number of nodes in the tree is minimum one. So like it is like one node definitely will be given. So let's consider that case. So scenario one, like when one node is given, right? So we have to do with the symmetric, we have to do first, we will implement the recursive solution. So as part of the recursive solution, so let's create one helper function, which is going to return true or false, and that the only function which is going to do everything for us. All right. So let's create is mirror, because we have to check whether uh, this binary is mirror or not. So let's create one function, and this is going to take two elements, one from the left hand side, one from the right hand side. So root dot left and root dot right. So it is going to take two elements, one from the left hand side, one from the right hand side, and only then it is going to do that. So we need to define this function. Let's define this function def is mirror, and it is taking node 1 and node 2. So node 1 is from the left hand side pointer, node 2 is from the right hand side pointer. That's it. We need to implement this logic, and whatever it, so this function is going to return true or false, and based upon that, asymmetric function is going to return true or false. So let's try to implement all the cases. So let's suppose if you have only one node is given, all right, then what you will do? So if only one node is given, you will check if node 1 dot left is none, because for if there is a one node, if there is only one node, then node 1 is this and node 2 itself is this, right? Because, right, just consider like node 1 is this, node 2 is this, node 2 is this, and like there is no left child, there is no right child. If node 1 dot left is none and node 2 dot right is none, then we have to return true, right? So because this is the node, this is both the node 1 and node 2. So we will check if the left hand child and the right hand child both are none, then we are going to return true. That's it, right? Okay. Because let's suppose if there is only root, right? So we are going to pass node dot left, node dot left and right element here. Okay. What else? Let's suppose, given with the case 2, so let's suppose there is a case 2. So in the case 2, we have the root, we have only left child given, we don't have the right child. So is this is a mirror tree? No, it's not a mirror tree. So there is a one condition. So what we have to do, if node 1, so node 1 is this, node 2 is this as well. Node 1 dot left, so node 1 dot left, node 1 dot left is not none. Because in this scenario, case 4 scenario, like you can consider case 2. So in this scenario, we have already covered this one. When like left and right both are none, then we have to return true. Now in this case, we need to return false, but we will put in the if else condition. So in this case, if left is not none, and node 2 dot right is none, then we have to return false. Okay, now so this condition is done because this is not a mirror, so this condition is done. So now let's see the other condition. What could be the other condition? Now we will focus on this condition. So in this condition, left is none but right is not none. So let's implement. So node 1 dot left is none and node 2 dot right is not none. Then again we have to return false because this is not a mirror. This is not a mirror because if you see here, if you see from here, we are expecting 2 here. It is not a mirror, all right? So this case we are already covered, right? This case also covered. Now let's see, one second. Now let's cover this scenario when we have the left child as well, when we have the right child as well, but the values are not same. If the values are not same, then we can't say it's a mirror, right? If the values are not same, then we can't say it's mirror. Okay. If node 1 dot value is not equal to node 2 dot value, again we need to return false. All right. Again we need to return false. So we cover all these scenarios. Now, like only the level 1 scenarios. Now let's suppose if you have given this tree, like this tree, this tree, or you can say this tree, any one of these where we have the more than one level, then what we can do is, earlier this is a node, right? So basically what we have to do, you think like what we have to do. Let's suppose, so node, like this is the root node, this is one is the root node in initial, it is passed, node 1 is this, so this is node 1 and this is node 2, right? So this is n1, this is n2. Now what we have to compare, the left of node 1 should be equal to the right of node 2, right? And right of node 1 should be equal to the right of node 2, right? So now we will consider, like we will just like call the same function again. So let's suppose first mirror. So we will first check like this part and this part, right? Then we are going to check this part and this part. So there's, let me rub this. Basically what we have to do is, 1 minute, what we have to check is what we want, the left, because three and, because in this case too we know it's, we are returning true and it's a mirror. But how we are saying it's a mirror? Because then how we have to check, if we consider this two node, this two, uh, this two node, this one, this two node, what we have to check, the left, this is the node 1 and this is the node 2. What we have to check, if the because node 1 is approaching on traversing on the left hand side of the tree and node 2 is traversing on the right hand side of the tree. So node 1 of left, node 1 of left 3, node 2 of right should be equal, right? So we need to compare this. So what we will do, we will call this function again, self dot is mirror. We will pass, what we have to pass, node 1, what we have to pass, node 1 dot left and node 2 dot right, node 2 dot right. We have to pass this. Then it is going to return whether true or false. Then second mirror. Second, in this second mirror, what we have to do? Node 1 dot right. So node 1 dot right and node 2 dot left should be equal. Node 2 dot left should be equal, like, because we don't know whether it is equal or not. We have to pass it to the function. We are just passing. Then we will check return first mirror and second mirror. If both are true, then we are going to return true. So that's it. Let's try to run it. So something is wrong. Solution pair 2 argument, but 3 were given. So return. Okay. So self. Something is wrong. Okay, the spelling of a node is wrong. Let's run it. Now our like sample test cases has been accepted. Let's try to submit it. Okay, none type has no attribute, right. Okay, node 2 dot right is none. So we have to put one more condition. It looks a none type object has no attribute right. So node 1 dot left is none and node 2 dot right is none. Then we have to return true. So which is perfectly fine. And let me check 1 minute. Okay, we did like some mistake here. Basically we don't, because we are already passing the left child. So we are passing the left child, then we can't again check the like left of left and right of right. Same thing here and same thing here and same thing here. I explained it correctly, but I type it wrong. Yeah, so now it's look right. So let's try to submit it. Now it's like, so like what we by mistake we did is because when there is a one node, we are passing the left and the right. We are passing the left and the right. Then we have to check whether the left is none and the right is none. I put left dot left, which is wrong. Also, so if I pass left child, then I'm checking the left is none and the right is not none. So that's what we have to do. Like node 1 is not and node 2 is not none. So let's try to submit it. So our solution has been accepted, but you see, like we beat only like 5% of the people in the runtime. Also, the memory, we consume a lot of memory because we are using the recursive approach. So we are beating, but anyhow the solution has been accepted. So right, so this is the like recursive approach. It's a simple question. What we just need to do is we just take a like pen and paper and like draw all the cases, and one by one just type all the cases. So the first case is node 1 and node 2 should be none, then we have to return true. If node 1 is none, node 2 is none, return true. Okay, so in this case, if node 2 is a node none and node 1 is like, if node 1 is so this case and this case, because we are passing the left and the right of the root, because we are passing the left and the right of the root. So if the left is not none and but the right is none, then again we have to return false. But if the left is none and the right is not none, then again we have to return false. But if both the values are like not equal, like in this case, case number 6, then again we need to return false. Otherwise what we have to do is we just call the same thing. But how we are going to call? Because let's suppose this condition, we want to compare the left of node 1 and the right of node 1 and the right of node and with the left of node, this node, right? The same thing we need to implement in the code. Let's try the iterative approach. So iterative approach is also very easy. So in the iterative approach, what we have to do is we will like assume, we will consider, let me rub this. What we will do is 1 second. Yeah. So in the iterative approach, we will consider this example because this is a little bit big example. So what we have to do is, so in the iterative approach, again, we need to compare like side by side only, but we can't call the same function again and again and again. All right. So what we have to do is we have to store these values somewhere. Right. So to store this value, either we need to use queue or either we need to stack. So let's use the queue, right? Because first come, first serve. Because whatever the element is coming first, we need to compare that element. So let's implement queue. From queue, import queue, and let's create a empty queue. Queue is equal to queue. All right. Okay. So we are creating a queue. Now what we have to do? So we have root is given. So let's put this scenario. This scenario we have root is given. We have because the root pointer is given. So in the queue, first we will going to put like the left and the right element. So queue dot put, what we need to put, root dot left and root dot right. We need to put root dot left and the root dot right. Then we need to run a loop on the queue. So let me show you on the whiteboard. So let's put this is a queue. So initially only there is a one element, right? And which is 2 and 2. We put both the left hand side and the right hand side of the queue. Then we will try popping this element until the queue is empty. All right. So while node queue dot empty, all right, until the queue is not empty, we are going to like run this operation. Now whatever the logic we write in the like in our recursive approach, now the same thing we need to write here as an example. So let's suppose there is only one node. All right, so if there is a one node, we need to implement using the queue. So what we have to do, so within the queue we are putting left child and the right child, and the left is none and the right is null. So there is a one box in the queue. We are putting the left child, which is none, and we are putting the right child, which is none, right? Then so right now in the queue this is there. All right, so now we need to pop this element. So let's try. So node 1 comma node 2 queue dot get. All right, so we will get the first element and the second element, right? So or if you consider this, so we are getting 2 and 2, or if you consider this, we are getting null and null. So if we are getting null and null, what we have to check? If node 1 is none and node 2 is none, if node 1 and node 2 is none, we are going to continue the loop because now the queue will be empty. We will continue. So we will continue. So continue means like this element has been removed. This element has been removed. This whole queue has been removed. Now we will continue. So if will come again, while queue is empty, yes, the queue is empty. If the queue is empty, we are going to return true. That's it. So this case is done. Let's come on the this case, right? Let's come on the this case. So this case is done. So let me rub this. Okay, so let's consider this case. All right. So in the queue, what we are putting left and the right. So we are putting two and null in a one box. So this is a first element in the queue, and we are like getting in the node one. We are like get the element, basically a kind of a pop operation. So in the node one we are getting two. In the node two we will get null. Then we will check if node one is not none and node 2 is none, which is the same case, then we have to return false. Straightforward, we are going to return false, right? Otherwise, let's suppose there are some, just let's consider this case. If this is the this case, we have to put here null. So let me rub this. So there is a queue. What we have to put? We have to put here null, and we have to put two here in the starting, because we have to put left and the right element. Then we are popping it. So in the node one this will come, in the node two this will come. So what we will say, if node one is none and node two is not none, again we are going to return false. Okay, now this condition also done. So this condition also done. So let me rub this condition also done. So now with this condition in the case 6, so we are putting in the queue, we are putting some element. What element we are putting? We are putting 2 and 3 together. So in the node 1 2 will come, in the node 2 3 will come. So we will check if node 1 not equal to node 2, then again we are going to return false. All right, so again we are going to return false. That is also done. Otherwise what we have to do, let's suppose in this scenario 2 2. So case 1, case 4, case 5, case 6 we already covered. Now come with the case 2 and the case 3. So let's cover this scenario. So in this scenario, first we put 2 and 2. All right, so we are getting some element, node 1 and 2, node 2. So here we are getting, so in the node 1 2 is there, node 2 is 2 is there. Okay, so element has been popped, so that's why this space is empty. All right, then we are checking if node 1 is none. No, if node 1 is not none, so this condition also not met, this condition also not met, this condition also not met. So all the conditions are not met, so it means this level is like okay. So now we need to insert some element. So q dot put, what we need to insert? We need to insert, so node 1 left and node 2 right. We need to insert node 1 dot left and node 2 dot right. We need to insert. We need to insert. So like this. And also we need to insert. So we insert 3 3. Also we need to insert node 1 right and node 2 left. Node 1 right and node 2 left. All right. And now, so we inserted 3 3 and 4 4. Now the loop will run again. Now we are like popping 3 3. Then we will check, okay, 3 3 is equal, which is fine. Now we will put the left and the right of 3. So uh, we are putting the node 1 dot left and node 2 dot right. So we are putting the left element of this and the right element of this. 1 second, maybe you might not able to see. So what we are doing is we are putting the left element of this 3, which is none, and we are putting the right element of this 3, which is none. So which is none. So none, none. So if both are none, then it is going to continue. All right. So it's going to continue because we inserted -1 -1, which is none. Then we are going to continue. Then we need to pop 4 4. So 4 4. So 4 4 is equal. Now we are going to insert the left element of this and the right element of this. So we inserted this 1 minus 1. So now we are going to pop minus 1, which is none none. So if none none, then we are going to continue. Then we are going to pop this. Then again continue. So now the queue is empty. If the queue is empty, then again we are going to return true. So this is like straightforward, easy approach. So yeah, this is straightforward, like a little bit easy approach. But let's try to submit this, whether this is running or not. So this is not running. So even the sample test case failed. So let's see what was the issue. So we are taking some queue. We are putting the left element. We are putting the right element. Then we are checking till queue is not empty. Then we are getting the queue. If node 1 is none and node 2 is none, then continue. If node 1 is not none and node 2 is none, then return false. If node 1 is none and node 2 is not none, then return false. If node 1 not equal to node 2, then return false. If node 1 dot value and node 2 dot value. So because we are checking the value, so let's try to run it. So something is there. Okay, so it should be node 2. Let's try to run it. Yeah, sample case has been accepted. Let's try to submit it. So more or less like this is also taking the same thing, because here also we are using some extra space, and this is also taking some time. So I know like this solution, because there could be so many solutions. You can go to the solution sections, and because many people, and we can filter by like Python 3. So people are like doing some solution, like they said it's a faster solution. So we can check their solution as well, but how they are doing. So there are, it looks like they are also doing in the same way. I'm not sure then how it is faster. They are also doing the same. They create the is mirror function and they are checking if none then true. They are checking the left and the right value. And along with that, they are returning first and the second. So it looks to me like everything same only. Maybe like what the thing is, uh, what the thing is like whenever we implemented this solution, let me go back. Whenever we implemented this solution, so we implemented a lot of if conditions. You can avoid this if condition by putting in one line, so maybe it will going to increase some like runtime. Okay, but anyhow, like this is the approach and our solution has been accepted by the both the way. So you can also try this solution, and thank you.